The diagram shows the curve with equation y is equal to x to the half minus 4 plus 3x to the minus a half. The curve crosses the x-axis at points A and B and has a minimum point at C. We're trying to first work out the coordinates of A and B. So, to do that, we would simply equate the equation of the curve to 0. So, y is equal to x to the half minus 4 plus 3x to the minus a half is equal to 0. So how do we solve this kind of equation? This is actually a hidden quadratic. If we multiply both sides of the equation by x to the power of a half, so times this by x to the half, and then times the 0 by x to the half as well, this will then become, so remember that we would add the powers. So the first term, x to the half times x to the half, would just become x to the 1, minus 4x to the half, plus, so these two powers add up to make 0, so 3x to the 0 would just be 3. And if I were to say, let's say z equal to x to the power of a half, this equation here becomes z squared. If you square this, you times the half by 2, and it becomes x to the power of 1. Minus 4z plus 3 equals 0. We can factorize this quadratic. It becomes z minus 3, z minus 1 is 0, and then we can solve. We'd end up with z is 3 and z is 1. Now remember that z is equal to x to the power of a half, so this becomes x to the power of half, or root x, is equal to 3. Root x is equal to 1. Square both sides, we end up with x is 9 and x is 1. So what have we worked out there? Well, if we go back to our diagram, we set this equation equal to 0. That curve is 0 at these 2 points, so we have worked out the x-coordinates of A and B. So coordinate A, which was on the left-hand side, would be 1, 0, and coordinate B, which was further to the right, would be 9, 0. Part B, find the coordinates of C. So C is the turning point that we have over here. Give its y-coordinates in this form. So insert form, something times root 3 plus b. A and b are integers. Okay, so to find the coordinates of the turning point, we have to differentiate. Let's write out our equation again. So it was y is equal to x to the power of a half. What was it, minus 4? Minus 4 plus 3x to the minus a half. So we first differentiate. This becomes a half x to the minus a half. Minus 4 differentiates to make 0. The second term differentiates to make minus 3 over 2, x to the minus 3 over 2. And we're setting this equal to 0 as we are trying to find out a turning point. At this point, the gradient, or dy dx, is 0. So how do we solve this equation? So if I were to times both sides by x to the power of 3 over 2, which is this number here but positive, I would get rid of any negative powers, and I would get rid of any fraction powers. So this becomes, if I multiply this by this, the powers add up. They add up to make 1. So that would end up being a half x to the 1. Do the same thing for the second term. These two add up to make 0. X to the 0 is 1. 3 over 2. That's equal to 0. And now we can just rearrange. So times everything by 2. X is then equal to 3. But we're not done yet. We figured out the x-coordinate for point C. We want to work out the y-coordinate as well. So whenever it says find the coordinates plural, not just find the x-coordinate or find the y-coordinate, we want to give both, x and y. So then we put that back into our equation for y. First of all, I'm going to rewrite this as root x minus 4. Now, x to the power of minus a half is the same thing as 1 over x to the half, which is the same thing as 1 over root x. So then the plus 3x to the minus a half becomes plus 3 over root x. We're putting in x is 3 into this, so then y would become root 3 minus 4 plus 3 over root 3. 3 over root 3 is just the same thing as root 3, if you were to type that into your calculator. And you should also be able to see that because 3 is the same thing as just root 3 root 3. So then y becomes root 3 minus 4 plus root 3, or 2 root 3 minus 4. So our answer is then, the coordinate will be, of C that is, the x coordinate would be 3, the y coordinate would be 2 root 3 minus 4.